Hello, everybody. We are working on Unit 4 today, and we are going to be talking about the topic of networking. And we're going to begin by kind of going through a few activities that hopefully will kind of enlighten you on how to discover information about your own network connection. Because obviously, all of those that are here in this session today that we're doing via Zoom, um, are clearly connecting through the internet. So whether you're sitting at home or at work or wherever, somehow you are getting on an internet connection, most typically probably through Wi-Fi or a cellular hotspot for most people. A few of us might even be hardwired. For example, I'm hardwired to my router here at home. Um, and what always I find interesting about talking about this topic of networking is it's one of these technologies that we've kind of grown now uh, to kind of take for granted in a sense because we don't really think about the fact that there was a day and age when computers did not connect to networks by default. Now we go out and we buy a Chromebook, a phone, a tablet, a desktop, a laptop, whatever, and we just assume Wi-Fi is built in. And if there's not Wi-Fi built in, there's a RJ45 jack where you can plug in an Ethernet cable, plug into your router, and you're online. And probably the trickiest part of all that is just typing the password for your router, and then you're off and running. And we really do take it for granted, and we've come into this age now where we don't talk about it as kind of an auxiliary setting on a computer. When I started in IT, computers were very atypically networked. It was not a common thing. And when we were in the workplace and we started connecting to our networks just to have the ability to print or to share a file with somebody or to send an email, and then more importantly, to surf the web, it really changed how people worked. It really changed how information was transmitted. And it also changed their expectations of what computers are. Because up until that point, a lot of people did not really use computers. The internet and its, I would say like it being a given when you buy a computer that you get online um, really changed everything. Um, but a lot of people, as they sit in front of their machines, have no idea about how they're connected or why they're connected. And if somebody asks them a technical question about it, they're like, I don't know, I'm on Wi-Fi. That's the kind of response you get. And it's not to belittle that, really. The thing is that for the most part, a typical consumer user of a computer does not have a functional need to ever really dig into the settings of their device, and unless there's a problem, and for most of us, we usually solve that problem by turning the router off and rebooting it, and then we're good. That's usually the fix, right? And so, from the consumer standpoint, that's wonderful because we've gotten to the age where it's easy to use. And I think we were talking about that in one of the other classes, like, when a technology becomes, almost transparent, that's when we have like a huge adoption of it from the general public. However, we are people that are striving to become professionals in this field. And so it is really kind of expected from us to know a little bit more than the general public. And the attempt here is not to teach you how to be a networking guru or to earn your CCNA certification or your Microsoft certification in networking. That's not at all the goal. We just want to give you some basic tools that might give you more information than the general consumer has. But you will run into situations where you might yourself have to solve a problem. And it's helpful to know where to go look for things and not be bedazzled about the information that you're finding. So we're going to talk in a little bit about the details of what everything means, but I'm going to kind of give you kind of the layman's explanation as we go. And you'll notice I have this little activity posted in the unit that I just added. It was not here last week when I activated the unit. I added it just before class started because I knew I was going to perform this function in class. And since all of us, I think it's already been established, are working on the Windows operating system, most likely Windows 10, we're going to use a few different techniques to be able to find the information on our computer systems that tells us how we're connected to the outside world. All right, and there's a number of different ways to do this. I want to start actually with the most, what do we call it, most primitive, but arguably maybe the most useful of all the techniques, by the way. And that is using a command prompt. Now, some of you might not even know what the command prompt is. So if you're brand new to working on computers at a high level, um, chances are you've never ventured into these waters. And what I'm hoping to do here is kind of expand the instruction set as we go. But for right now, I have the basics here. So if you guys want to follow along on your own machines, this is a good little exercise. And hint, 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 it helps you complete the homework below this posting, where you're asked some of these very same questions. Now, I typically, and part of this is because of my experience, kind of growing up with the IT world as it moved from like a command prompt era into the Windows era. In the old days, when we operated our computers strictly from a command line, it was quite a revelation to be able to do things in a windowed environment. But we still found ourselves being able to do sometimes significantly more powerful things from a command prompt than we could ever do from within a windowed environment, especially if you don't know where to look, right? So let's talk about how to get to the command prompt first. So step one is just to go to your Windows Start menu, like I did, and then just type the following command on the keyboard, CMD. And what that'll do is it should bring up, in just about every version of Windows, the command prompt application. And I'm going to go ahead and launch that. And then you see that I have the command prompt up on my screen. It does come up in a windowed environment. And by default, it should place you in your user folder within your operating system. And where we sit folder-wise in the operating system is pretty irrelevant for the task we're about to perform. But I do want to just give you the very brief anatomy of a command prompt. But this is basically indicating to us that we're on the C drive in the users directory in my personal folder, and the cursor is flashing, waiting for a command. And the way that a command line environment basically works is like this. You type a command and you press enter. And then it does, hopefully, the command that you asked for. Sometimes it's running a program. Sometimes it's just doing a directory listing, which is what I just did. So you see, I just typed this simple command, dir. I pressed enter, and then it gave me a listing of all the files and folders that are in my user folder on my machine. All right, and that's the anatomy of how a command works. There's a whole school of study to learn how to operate a command prompt, and that's not my objective here at all. But I do want to teach you how to type one very useful command called ipconfig. So it's ipconfig, and I'll just wait here a second while you guys copy that. And this is one of these basic commands that was developed as soon as networking was added to the operating system of DOS. They added this command so that you could basically diagnose your status. You want to know what your status is when you're connected to a network, like, are you connected, for example? And if you are connected, what's your IP address and how are you connecting to the outside world? So once you have that typed in, so once again, ipconfig, all lowercase, no spaces in between, and press enter. Now you can see on my machine I have a significant number of network interfaces, and most of you probably will not, by the way. And I have a couple of Ethernet adapters, so you can see that I'm hardwired not only once but twice here. And the reason that I'm listed twice is because I do run kind of like a complex environment, very frankly. But for most of you, you're going to see either an Ethernet adapter or a wireless LAN adapter that says Wi-Fi. And then depending on which one you're connected to, so you can see right now, I'm not running on Wi-Fi. I'm running through a wire called Ethernet, right? And that means I'm hardwired from my machine directly to the router. If you're wondering why I do that, here's why. I get more bandwidth, so we go back to that term again, which is the amount of information that can flow back and forth from a wired connection than I would from a wireless one. I can get the full gigabit speeds that my router offers. Now, granted, that gigabit speed does not go past my router to the outside world, but from my machine to that router and any other device on my network that's hooked up the same way, I have max bandwidth possible available. I also find that a wired connection is significantly more stable. So, in other words, if I'm uploading or downloading a file, even if the bandwidth hypothetically is similar, the wired connection will be more stable and more consistent. It's particularly true for upload speeds, by the way, much faster typically on a wired connection. The other thing about a wired connection that I really like is it's significantly more secure. The way a person would have to hack into this is they'd have to connect to my network and try to route through the router and stuff and get to my machine. With a Wi-Fi connection, your signal's flying through the air. People with the right technology and know-how can hack that, even with secure passwords. So I want you to...
I was
Yes,
just
go
going to
ahead.
ask you a question. When you say you're directly connected, that means you're not like directly connected into your router, right? You're directly connected to your actual internet cable, I guess. Is that
No,
correct?
that's not correct, Cindy Lou.
Oh,
No, I am connected. In fact, I have kind of a complicated home network, as you might imagine, for being the geek
mhm.
that I am. So we have a cable modem, and then it goes to a central router, and then I have two additional wireless routers on both ends of the house. So we have a really long house. It's probably like 80 or 90 feet long. And so I
Mhm.
have, one router in the middle, one wireless router, another one at the front side of the house, and one at the back side of the house. And all that is wired together through wires. And then some devices connect through Wi-Fi, and some are hardwired. In other words, I have a wire that's plugged into my computer, and that wire is plugged into the router right next to me.
Okay, so you are plugged into your router then.
Yes, I am.
Okay.
That's a good question. Now, when we look at this information here on this screen, I want you to notice some really key pieces of information. And part of your assignment is to find these things, by the way. And what we're really typically looking for, and it's a very common troubleshooting question or issue, is to find the IP address for your machine. So on this screen that you see right here, where we're looking at this Ethernet adapter, this is the IP address for my machine. But with a very important distinction, this is the IP address for my machine on this network, on my local home network. So somebody within my building here could ping or locate my address within my own network. External to my home network, nobody would ever find that IP address. Right? And there's actual IP address ranges that are considered private and some that are considered public. Now, anything that starts with a 192, 168, that's typical for a lot of people, or a 172, like you see on my screen, and I forget the other one, on the enterprise level, usually a 10 dot something. Those are all considered private IP address ranges. All right, so for my local network, all of my IP addresses for all of devices in our local network start with 172.16. You'll also notice that there's another entry here down below that says default gateway. This would be the IP address of the master router on my network. So all traffic has to route through this device, whatever this device is, and I know it is. I have a big Netgear Nighthawk router that I paid several $100s for. Really robust device with like 6 antennas and tons of lights and lots of features and whatever. And the IP address for that main device is 172.16.0.1. And if I ever want to do maintenance on my network, so log into the router, for example, I can do so by going to that IP address. In fact, I'll demonstrate that because this is kind of another one of these things that we're doing here today. So you can see it'll auto connect me here. Oh, and I'll tell you why that's happening, because I'm connected to school right now. And this is kind of interesting. So I'm actually going to disconnect from my VPN. You guys might hiccup a little bit on the internet connection as I disconnect. And so what this is telling me, by the way, as I keep recording, is that I was actually connected to the school campus. And now that I'm disconnected, and oops, all my screens went away here. All right, now I'm going to go back to my browser and hit that same IP address. If I hit that gateway address, now it's asking me for my admin, and here I am logging into my router at home. And so that And this is really bad because my passwords pop up in there too. So I'm clicking off of that super fast. And hopefully don't go back and watch that video, okay? But I'm going to close that tab. Damn. Okay. So now my passwords are out on the internet. Fantastic. That's as bad as a post-it on your monitor, folks. All right, but that's how I get to one of my router login pages. And I know that this is the master router because of the gateway address. There's this other thing here called the Subnet Mask, and this goes more deeply into network philosophy and address routing schemes. But for most home networks and most small networks, almost always, as a general rule, the subnet mask will be set exactly like this, which is 255.255.255.0, which means that you have available to you a total of 256 different addresses within this IP address range. So it'll go from 176.0.0 all the way up through 17.16.0.255. And so your IP address in your home network will always sit in that range. All right, and I think that's pretty helpful to know. You are going to notice, for example, how and this is the tip, right? So how did I know, that my router would fail like that the first time I tried to hit it? See, I was also connected to the gateway system, so I was getting a separate IP address from them. And what's kind of interesting here is I'm going to retype the command and take a look now and see that that other Ethernet adapter is now disconnected, right? Because that was my external VPN connection. So now I'm just on my local network. I do also want to point out the fact that a number of years back, they decided that the IP version 4 addressing system, which was all numeric, had limitations. And because of that, they had to come up with really clever ways to work around it to allow all the different computers on the internet to connect to the network. And so they came up with this new version of IP addressing called IP version 6, which uses hexadecimal values instead of just base 10 numerals. Hexadecimal values are base 16 number systems, so the numbering goes 0 through 9, and then A, B, C, D, E, F. So it's 0 through 15, with A through F being 11, 12, 13, 14, and 15. And so that's why you see mixed letters and numbers here. But this addressing scheme here, the IP version 6, provides enough unique IP addresses for planet Earth to address, I think it's like 1,000 devices per square foot of surface area of planet Earth. So hypothetically, that should be good for a while, where the IP version 4 scheme provides significantly less. All right, so that's one way to get your IP address. Let's look at a different way to do it now. The second way that we're going to do it is another somewhat old school approach in Windows. Now, most of us now are using Windows 10. When we were using older versions of Windows, if we wanted to make changes to the settings of Windows, we would typically go to the Start menu and we'd look around and maybe even do a right click. And on the list here, there would be a thing that said Control Panel. And the modern versions of Windows, especially in the last couple of years, are trying to remove that. They don't want people using it so much, but it's still there. So you can go to your Start menu and just simply type Control Panel, and you will bring up the old school Windows Control Panel. And you will notice here straight away there's a Network and Internet section, including a View Network Status and Tasks area, which is where I want you to go. So when you come here, you're going to notice it's looking at my network connection. It tells me which of the routers I'm connected to and how I'm connected. And then if we want to look at the device that we're connected to, so you can see right here I'm connected to Ethernet. If I click on that, it brings up this status screen. From this screen, it tells me a bunch of different things. And, for example, my IP version 4 is how I'm getting to the internet. It looks enabled. Here's my speed. Here's my duration, my uptime on the network. But this little button here, Details, will give me some of the same information that we are pulling from the command prompt. And so this is a very useful screen. So you can see, if you look, a couple of additional things that are listed that are not available on that other screen. So in some ways, this screen is a little bit more verbose and useful. However, there are ways from the command prompt to get this more verbose information too. And by the way, if you want to know that trick, I guess I should just show it really quick. The trick is you just say IP config /all, and it gets a little bit more verbose. So now you see all that same information that I have on this other screen here is actually here as well. So I just want to show you that. Once again, the command you type for that is ipconfig /all. Okay, so I'll just leave that kind of off to the side. But now if you look at the screen, once again, it does give you your IP address. It gives you your subnet mask, and it also gives you your gateway. Notice it gives you a couple of other things too, and this is kind of interesting. Once again, IP version 6, but then it says, where is your DHCP server? Now, the DHCP server, what this stands for, by the way, is Domain Host Controller Protocol, which means that there's a machine on your network somewhere whose responsibility is that when you connect to that device, it gives you your IP address. It says, okay, let's see what we got available. Oh, yeah, you can take .10. So that's a DHCP server. So that means that, for this particular device, I'm getting my IP address through DHCP. It's automatically assigned. You can also manually assign the address, and that's where we're going to go next, by the way, is we're going to look at that. But this provides very useful information. There's also a little thing here that says, where's my DNS server? And that points me back to my router. And then my router actually has a special page on it, by the way, that has, which DNS servers I'm connecting to, not from my own network, mind you, usually from my internet service provider or any third party that I designate. So a lot of people have this thing now, by the way, where they prefer not to use their ISP DNS. So for example, like if you have Time Warner or AT&T, which most of us do, they have their own DNS servers, but a lot of people are like, I think I'd rather use the Google ones because they're more robust and more accurate, more complete, by the way. And so you can manually go into your router sometimes and put in the Google ones, which I think it used to be 8.8.8.8 or something weird like that. Very easy to remember. But you can Google that and find it and actually manually change your router to it. And the beautiful thing about that is if your internet service provider ever goes down, like their main DNS goes down, it does happen, by the way, then you kick over to Google's, automatically, and theirs is always up. It never, ever, ever goes down because they have it replicated so many times all over the planet. And that's pretty fascinating to think about. All right, let's get out of these boxes now and go to a different way to look at the same information. And you can also click through this adapter settings thing, and I'm going to show you this here, and then I'm going to go into the modern way to do it. And so if you're in the control panel, so I just want to show you how I got here, and you go to network and internet, you end up here. But if you want to actually look at the adapter settings, and that is kind of the trick, right? Let's go, well, I guess they don't have, I thought it was on the menu here, but apparently I'm just completely wrong. But you want to look at these adapter settings where it shows all the different networking devices you have connected. All right. This is my main connection. How do I know that? Because it doesn't have a red X on it, for one thing. And I know which thing I'm connected to. So I'm going to right click on top of that and choose properties. And it brings up a special screen here that's kind of interesting. So first thing it does that's fascinating is it tells me which device I'm using to connect to the network. And for most of us, this is kind of an automatic. We never have to mess with this stuff. But I'll tell you, in the old days of networking, like when networking was brand new, oh my God, we would spend hours in here trying to make stuff work, when it wasn't quite so easy as it is now. But for every device that you have connected, usually you need special drivers, and then you can go in here and you can configure those devices and do all sorts of advanced things. But that's not something we typically have to do at all these days because most of the drivers are automatically loaded by Windows 10, by the way. But you'll notice in the bottom part of the list is really what we call a collection of the protocols and services that are attached to that network adapter. And I just want you to look at this really carefully. Your list might be a little bit different than mine, by the way. So I have a client for Microsoft Networks, file and printer sharing, VirtualBox, that's a virtual platform that I have, Qos Packet Scheduler. Does anybody know what Qos stands for? Quality of service. You know what it's used for? For making sure that our streaming content streams well. So when, like, in other words, this particular tool is there so that when I'm streaming a video, it will prioritize the streaming video traffic over other things so that I get a smooth video playback. You know, maybe prioritize it over print traffic or chat traffic or whatever. Then once again, we see that Internet Protocol version 4 here. That looks familiar. And then a whole bunch of other stuff, you know, most of which is completely irrelevant for most users, by the way. But this one is one that sometimes you do have to play with, especially if you're on a network where you're required to have a static IP address. In other words, you're not getting your IP address automatically from your router. You are manually entering it. And some people, especially in work environments, will use this on purpose so that they know which address goes to which machine absolutely, you know, without having to automatically assign it and then try to track down which one is connected to. And so if you do have this set, you can find out very easily by just simply highlighting that entry. And this is part of the exercise, by the way, where some of you might have gotten hung up. And then you click this properties button. Now, for most of us, this will be set to obtain IP address automatically, which means DHCP is being used and the IP address that you have was automatically assigned. If instead you have this circle pressed and there are values entered here, these were manually entered. And this will be most common, frankly, in like a enterprise or business or work environment. Typically not typical at home, with some exceptions. So here's some exceptions. Gamers, right? So I'm looking at my son. My son is gaming all the time, and he hosts, I think, like a Minecraft server, a TeamSpeak server, you know, yada yada yada. And the gamers know what I'm talking about. And in that case, for him, it makes more sense to have a static IP address so that the outside traffic from the rest of the world can always tunnel into his machine specifically. Also, if I was running a server at home that was a web server or a file server or whatever kind of server, and I wanted the outside traffic to always go to that machine and not mistakenly go somewhere else, I would set a static IP address. Static refers to non-changing. And so you might, you know, by some anomaly or intent, probably the intent part, have someone that set up your machine to have a static IP address. And for that exercise, you might need to come here to find that information. The other interesting thing about it is if you need to change those settings, sometimes that happens too, this is where you do it. So if you need to set a static IP address, you can come in here and manually control it. All right, so that is the properties window off of IP version 4. That covers, you know, what I would call, you know, all the old school ways to get the information. Now, there is also what we call the new school way, which is to use the Windows 10 settings area. And I assume that most of us will probably do that now. So when we go to our start menu, we'll go to the settings icon and it brings up this fancy new Windows 10 interface. And if you guys haven't caught on yet, Windows and Microsoft really prefers we use this instead of control panel now. And the real hope of it is that we really don't have to come in here too much to do anything. That's what Microsoft prefers. But you'll notice there is a network and internet area. So if you click on it, you will notice you can get to some of the same kind of information. And I want you to just to notice here, here's the status screen. And it shows me what I'm connected to. It says Ethernet 5, that's whatever it is. And if I want to view my network properties or change my adapter options, I want you to notice what happens when I click on these things. So they kind of bring up the same information, right? So it shows all my different connections, just like it did from the command prompt. And so I have to know I was connected to Ethernet 5, And there's all that same information here. Without digging into all those old-fashioned cryptic looking screens, it is available from the modern front end. And just once again, to just repeat how we do that, we go to settings, we go to network, and then you just view your network properties, and it's all there. Okay, so that's an easy way to do it as well. I'm going to pause the video here for a sec, and I'm going to ask a couple of questions to you guys. One little discussion we've been having since I paused the video here is how some people's network status screens actually have different information on them. And for me, to see my network properties, I clicked on this link. Cindy Lou, on your machine, it was called what?
It was called View Hardware and Connection Properties.
Okay. But functionally took you to the same place, right?
Yes, it did.
Okay. So that could be that maybe my computer's more up to date than yours, or vice versa. So maybe I have a Windows 10 update you don't have yet.
Well, yes, I do need to do an update here.
So that could be just a very simple change like that.
May I ask another question then?
Sure, absolutely.
While I'm looking at this screen, my IPv4 address looks totally different than the one we saw in the command prompt or in the control panel.
Okay, well, if that's the case,
well,
I want you to notice, like, for example, I have like connectors here that have IP addresses, and you notice how this one's completely different too, but this is not a connected device.
Oh, okay.
See, this is the only one that's connected, and my IP address, I'm trying to find just my IP address here. Yeah, it's actually not even listed there, is it? This is the network information. No, there it is, right here. This is my IP address.
Okay. So you just have to scroll down a little bit.
Yeah, just have to scroll down a little bit. And if you're like me, most machines will typically have a wired connection and a Wi-Fi connection and maybe a Bluetooth connection. And then if you run any funky software, virtual machines, VPN connectors, or whatever for work, you can end up with a whole bunch of them, by the way. All right. Let me move us now to the next little tidbit. And I just want to mention that right now we're in a session where everybody is working on Windows. If we were working on different platforms, I could show you how to pull the information from the different platforms. But here's a really quick little trick, by the way. And I'm just going to type this into my Notepad++, by the way. If you're on a Macintosh and you know how to get to the terminal, or if you're on a Linux machine and know how to get to the terminal, which is their version of the command line, you can type this command. Notice how it's really close to the Windows command. The Windows command is ipconfig. On Linux and Unix machines, the command is ifconfig. And if you type that at a prompt and press enter, that will also give you the information from the command line. Now, with the graphical versions of any operating system, whether it's Mac, Linux, and Linux has like 1,000 different distributions to it, about 4 or 5 major ones. How you get to that stuff graphically will be different in every operating system. With a Macintosh, you go to System Preferences, go to Network, find your connection, and all the information will be right there. But from the command prompt on all Linux and Unix machines, this command will work. I do want to say that there's a couple Linux distros that have changed this command recently. And I can't quote for you from memory what the change is, but I think when you type this one in, they'll give you a little message on the screen that says, oh, we switched that to type this instead, and you do it. All right, I like to record that into the video just so we have it. All right, welcome back from break. We are now going to talk about the other one of the other activities I have here in the course shell. And this next activity is kind of a fun one too, I think. But before I dig into it, I do want to just kind of point out really quickly, this networking unit, right, is one of those that's based on chapter 3 of our book, and the PowerPoint is here, and I am going to talk about some concepts from here pretty soon, although that's not my primary concern because I know you can read on your own. But I do want to point out that I gathered up one of my predecessors here who taught this course, made a course copy for me when I was teaching this, and left in the resources folder and in the networking folder here what I call a wealth of networking knowledge. And I was just kind of blown away by the depth and the complexity of it. And I don't know if you guys had a chance to dig into this or not, but it's all in this separate folder. So if you follow this link here and go into this folder, they have all these extra readings, additional PowerPoints, explanations about topologies, nicely laid out and explained with bullet points and everything, and a whole bunch of video links. And I mean, there's like what, 30, 40 videos, 50 videos here, all dealing with networking. So if you really want to deep dive on this, here's this like excellent library of stuff that you can explore. I do not require you to check out all that stuff. It's impossible to do so. The stuff that I consider critical, by the way, is all the stuff in the surface level of Unit 4. So read the chapter, check the PowerPoint, check the readings that I point out, and then maybe watch this video, who knows, once I post it, which will show up right here. I do want to go now to this little silly activity that's really not quite so silly. It's actually kind of a fun one to do. Some people are very aware of how to do this and have done it before. Other people are completely new to it and never have done it. And there's this thing that often, like let's say you're at home and you're having a horrible internet connection, or your Zoom session here is failing or something, and you're getting choppy video. One of the problems that we have when we're networking and we're connecting over the internet is sometimes we don't know where the problems in our connection really are. Is it in our own network? Is it Time Warner or AT&T or whoever else is your internet service provider? And we have some tools available to us that allow us to actually track down some of the problems. But one of the funner tools is actually determining your internet connection speed. There's this company out there called Ookla. It's kind of a weird name. And you can actually go directly to their site to do this search. But what they've done is they've kind of partnered up with Google. And notice I say here, you can simply search Internet Speed Test to bring up this tool. So if you do go to your browser and go to the Google search engine and just type Internet Speed Test, right into the top result in your browser will be this tool where you can just literally hit the button right here in the browser right after doing the search and run the test, which I'm going to do in just a moment. But I want you to notice that this is not developed by Google. In fact, this is provided by this company that has the first link here, which is considered kind of the preemptive place on the internet where people go to do their tests for speed. And notice the URL for that is speedtest.net. But I don't know how they came up with this arrangement with Google, but they're allowing Google to run it right in browser here. So I'm just going to hit the button, and I just want to show you, this is my connection at home on this particular machine. This first part of the test is testing the download speed to my machine. The second part, this speed, is testing, notice, the upload speed of my connection. All right. So I'm getting about 90 megabits down and 10 megabits up. Now I will preemptively say, I am sharing this network with other people. So I know with a high degree of certainty that I have two teenagers upstairs that are probably both like streaming videos, gaming, watching Netflix, and gaming and chatting probably all at the same time on multiple devices while I'm doing this. The service that I pay for, by the way, from Spectrum, I use their base level service, which provides for most of its customers, if you've switched to the Spectrum service, not the Time Warner service, and that's an important distinction, their base level service is 200 megabits down. And usually when you buy bandwidth from a service provider, you're paying for the down speed. The down speed is the speed from the internet to your machine. And if you think about the way that you use the internet, it's that speed that's most important to us, because we want to be able to stream those videos. We want to be able to do our Zoom sessions. We want to be able to download a file really fast, those types of things. The up speed, notice, is usually a fraction of the down speed. And the up speed is the one that, for example, for me, is sending my video, like my face and my voice, to your machine, and my screen share. That's going through my upload connection. And notice it is a fraction of the download speed, usually about a tenth, by the way. That speed is pretty normal for most consumer internet plans. If you were to look at this same information, if I went to the Gateway campus and ran the speed test, we would get a very, very different result. So for example, if I was on campus, typically I would be getting about 200 to 300 megabits down, and usually anywhere from like 300 to 1,000, basically a gigabit up. And that always astounds people because that's so much different than your home. But when you think about a campus network where we connect to Blackboard and email, and well, none of those services are on campus, but any of the other services, Gateway has servers on campus that need to send the information to the users faster than we need to receive it from the user. So it's very common in an enterprise environment, especially where servers are being run, that the up speeds are faster. A number of years back, when I really didn't know any better, I used to actually run web servers as part of my business. So in other words, I would run a web server and sell space on my server to others. I was hosting websites. And in that connection that I had to pay for what we called a synchronous connection, where the upload and the download speeds were the same, because most of the people that were hitting my network or my server wanted to be able to download from my server as fast as possible. And so my upload speed would then affect them most significantly. I don't see really a functional need for most home people to have a big upload speed unless you're running a large number of servers on site where people need to connect to them. But this is a really interesting result. And I want you to notice too, that when I ran this test, notice it's connecting to a server that's geographically close to me. So it connected to some server down in the Chicago area, and my latency is 7 milliseconds. Does anybody know what a millisecond is?
Thousandths of a second?
Perfect, Cindy Lou.
Oh.
That's exactly correct. 1 millisecond is equal to 1/1000th of a second. So my round trip from my Milwaukee location to the Chicago server and back takes 7 thousandths of a millisecond. Imperceptible delay. That's incredibly fast, by the way. Even if my bandwidth is somewhat limited, the latency is how long it takes to respond in a round trip. So a lot of gamers know this setting, right? So if you're playing like, some like online game, you're always looking for that server that's got the lowest latency, right? Because because if your latency is like 300 milliseconds, that's a third of a second. That's enough for somebody to shoot you in a first-person shooter game before you even have a chance to respond, right? So gamers know that one pretty well. So this is an interesting test to run. If you want to get the most accurate results for your internet connection, wait till everybody's asleep, all the devices are shut down, nobody is streaming, then run the test and see if you're getting the real speeds from your internet service provider that they claim that they're giving you. A lot of people are shocked that very often they're not getting the full speed that they're paying for. I will tell you, it depends on the service that you're using. Typically, if you're using AT&T, you get exactly the full download speed. If you're using Time Warner, it will vary, where you can get anywhere from significantly less to significantly more. And that's because of the architecture of their network. Their network is designed that it slows down when more people are on it. The AT&T networks have controlled bandwidth to each user, which is kind of fascinating. So which service is better? It depends. If you want a stable speed, you go with AT&T. If you want potentially faster than what you're paying for, you go with Time Warner. And is it worth paying to get more speed? I'm going to argue yes. If you have a lot of people that are doing what we're doing now, which is they're Zooming for school, like during the daytime, my daughter's Zooming while I'm Zooming. And other people in the house are streaming stuff at the same time. I've been thinking about very seriously upping our bandwidth, because it doesn't cost much to increase your speed often. And now that, we don't pay for cable TV, and we're like, well, we'll just pay for internet instead, right? Because we stream everything. But this is a fun little test to run. And there's other services that provide it too. So you can come here and you can test, AT&T has their own, Spectrum has their own. You can see everybody has their own. But I like using this one because, once again, you guys saw how easy that was, and let's see if it changes this time. It'll probably be pretty close to the same.
Mine's pathetic compared to yours.
I'm sorry to hear that.
But
you know what?
It tells me my internet speed is fine. I mean, my download is 8.33.
But Cindy, that might be exactly what you're paying for.
But, well, I don't have, I don't pay for very much. And I'm running Wi-Fi off of Wi-Fi right now as well.
Yeah. And you know what happens? Sometimes Wi-Fi slows you down as well.
Sure.
So I was blown away when I switched from from wireless to a wire at home. When I would run these tests and look at the difference in speeds, and oh my God, I was like, right, I'm getting that speed to my router, but I'm not getting it to my machine.
Mm-hmm.
And so, like, if you really want the speed, and I say this to the gamers in particular, or the people who really want to stream content with no interruptions, hardwire is always better. So don't run your TV on Wi-Fi. Run it through a hard line if you can. Just a helpful tip. All right, so that's a silly little activity, but at the same time, I think it's super useful because a lot of people, frankly, don't know how to do this. I think it's a very useful thing to know how to do. Just one of those things that you can test. And then if you go to your work locations, try this at work. Heck, try it on your cell phone with your internet service provider. So like if you're like Verizon or AT&T or T-Mobile or whatever your phone provider is, you can run that on their network too. And here's the thing that you will be amazed at. Your cellular speeds are typically way faster than your home speeds. And that's kind of mind-blowing for some people. That's not true everywhere, but in certain locations, I was always blown away when I would be at the Racine campus and I have US Cellular for my cellular provider, and I would be getting like, oh my God, I'm getting a gigabit down, downloading a file. That's like 10 times faster than at home. Just blew me away, and I'm on cellular. But I come to downtown Milwaukee, run the same kind of download. It's half the speed or a quarter of the speed, and it makes no sense. But it's kind of interesting to check it. See if you're getting what you're paying for. All right. The next thing that I want to do is I do want to kind of go into some lecture-y stuff, but I'm going to avoid the PowerPoint for right now, and I want to kind of more informally talk about networking as a concept. And I want to begin with this concept of what it means to communicate. And so, can somebody tell me, like, if I was just to generically walk up to you and say, "Hi, I'm not from planet Earth. What does it mean to communicate?" And you would answer,
maybe like how we like relay ideas to each other so we can understand what we're trying to say. I don't know.
Austin, I like the words you're using.
Yeah.
Okay. Anybody else have a thought on that?
An exchange of information.
Exchange information. Austin, what are the words that you used?
I think I said, yeah, I think I just said like exchange. I think I just said like exchange information so that the other person like knows what you're trying to like convey. It's like conveying maybe not like a tangible thing, but conveying some kind of like conceptual thing to them so that they like know what you're talking about.
Okay. Any other thoughts? Okay. And I think these are pretty accurate, but what it really comes down to is communication is really about, I'm trying to send you a message and I want you to get the message and receive it and understand what I mean, right? And the message might just be, hey, do you want to go to the store? Yes or no, right? Or it could be, how many cartons of milk do you want? And what if you can't actually use words to communicate information? And this is where it gets kind of interesting. Because if you're talking to somebody, and here's the other part, and you speak the same language, this is the connection to networking. I can send you a message, You can hear it, understand it, and then maybe even have a conversation with me, but you get my intent, you get my meaning, and you get the details. But there's so many points along the way where things can fail. And what happens if, for starters, what if you don't speak the same language? Well, now you got a deeper issue, right? Well, you both know how to talk, you both know how to converse in your own language, and you want to send a message, but how is the other person going to receive it? And so when it comes to communications, there are protocols in communication where if you want to understand each other, you have to talk the same language. And that's a real big one. Now, can communication be done without speaking? Obviously.
Sure.
Right. What's an example of communicating without speaking?
Signing.
Okay, sign language. Perfect. Another thought?
Just like
Letter.
body language.
Aha, yes, body language. You don't have to say a word. I can tell you're sad because, hey, you're crying, right? Or I can tell you're happy because you're laughing. Sign language. How about writing, right? Written word is a thing too. So I don't have to speak to you to get a message across. Still getting the message across, not maybe as elegantly. You might not get all the inflection in it. And then we have, for example, even if the words are written, people are often misunderstanding what you write, right? And that this is even more true in this modern world of texting. You guys ever hear the little analogy of like something like this? I can read it like, do you have the pen? Or I could read it like, do you have the pen? Do you have the pen? It could, right? And all of that has a different meaning just because of the way I'm emphasizing certain words. And that's not encoded in this message. And I think that's pretty fascinating. Now, the thing that blows me away is that regardless of how old human culture is, and the jury is still out on this, civilized society, some people think only goes back a few thousand years, but they are finding more and more significant evidence that it goes back tens of thousands, maybe even hundreds of thousands of years. And people have been intelligent that whole time. They've had language, they've had ways to send messages to each other. And very often in the ancient world, they would come up with really clever ways to send messages over distances. So it's really easy if I want to say to one of you, hey, go to the store and buy a carton of milk, right? But if you're at a distance, like Cindy Lou, if you're in Racine and I'm here in Milwaukee, and I say, Cindy Lou, go buy a carton of milk, but I don't have the Zoom tool or my phone to use, how am I going to convey that message to you? Well, I could write a letter, right? Type it up, put it in an envelope, put a stamp on it, take it to the post office, give it to the mailman. A couple days later, it shows up in your box. You open it and go, okay, I'll go get some milk, right? Pretty slow. But in the ancient world, they had the need, just like we do today, to try to convey information instantaneously. And they came up with some really clever ways to do it when they didn't have technology to help them, not at least the kind of technology that we have. So one thing that they came up with is using visual signals. So for example, the Romans very commonly would set up this network of, like people that would sit basically on top of like prominent locations, like mountaintops or hills or cliffs or whatever. And they would just sit there and wait and look. And their job was to look over at the hill on the horizon. If you saw a fire lit on that hill, that meant that, the barbarians are coming. If you saw 2 fires on the hill, they're coming by sea. So you see 3 fires on the hill, they're attacking now, help, something like that. And they would use, signal fires, they would use smoke signals, they would use other sorts of physical markers that you could spot from a distance to convey a message. Because visually, the line of sight happens basically at the speed of light instantaneously. And so they had entire networks. The ancient Greeks, right, if they wanted to shuffle a message off from, let's say, one king to another, that's where the whole concept of marathon came in, right? They didn't necessarily even have horses. So they're like, all right, I wrote up this message. Here's the parchment with the message. Okay, run. So they give it to the guy. And the way they came up with the name Marathon was because the guy would run from Athens to the town of Marathon to deliver a message. And it would take him, it was like 27 miles or whatever a marathon length is. And hopefully the guy made it there alive, that he didn't like run out of breath or get killed or whatever. And sometimes they would have a series of riders. And even here in the United States for many years, before trains were around, they had the Pony Express. If you wanted to get a letter one side of the country to the other quickly, they would literally give it to these horseback riders that had a whole system of like fresh horses and riders all the way across the country to deliver things quickly. And I want you to think of how far we've come, because what we've learned how to do over time is to send messages absolutely instantaneously. If something happens in the world, 3 seconds later it's on Twitter, 1 hour later it's on your news feed, 3 hours later everybody's talking about it. What's the big news story happening right now? Not political. What? What's going on?
Texas is frozen.
Yeah, Texas.
Texas is frozen. That's a big one. But there's something else happening up on Mars, and I'm using this for.
Oh yeah, the rover.
Yeah, the rover is landing.
Yep.
Here's the fun part. We don't have real-time communications, even though it's traveling at the speed of light with all the technology we have. Our signal is delayed, I think, like 17 minutes. So the rover does its thing. 17 minutes later, we get a signal back on Earth at the speed of light. It's as fast as the message can get there. I want you to think about that. That's kind of bizarre, because that's how far away Mars is. And that's not even very far. Now, with us, what we've done in modern society is we've learned since the mid-1800s that we can take copper wires connected to a power source and create some very primitive technologies. And the first, primitive technology that we developed, and I'm trying to type the word telegraph, but it's not letting me here. Let's try that again. We came up with this technology, the telegraph. Telegraph was very, very primitive. In fact, it literally was 2 copper wires and a power source connected to a series of devices like this. And you would tap the device, and it would close the electric circuit, and then on the other end, the device would repeat that tap. And so they came up with this whole system called the Morse code of like taps, long taps, short taps to represent letters of the alphabet. And then by the mid-1800s, I think it was 1835, the telegraph was invented, but by the mid-1800s, like 1850s or 1860s, they laid the first transatlantic copper wire cable over to England and were able to telegraph from New York City to London. I want you to think about that. Messages at that point, instead of having to take, all right, here's a letter, get it to the president. This is the Queen sending it, right? 2 months later, the boat arrives and here's a letter. That was as fast as they could go. And now you have this instantaneous thing where you have these people tapping out messages and the message is instantly received, completely transforming the way we communicate, folks. That device right there blew open the whole thing. Now, interestingly, that transatlantic cable failed almost immediately. As you can imagine, the logistics of running a wire that long and then not having it like snag on something or having a fish eat it or the connections break. But then they replaced it eventually, I think the year after, and that wire stayed in service for almost 100 years. They were sending messages over those wires. Mind-boggling, really. The technology ramped up very quickly, and then we had several people working on this device all at the same time. And, everybody credits, Alexander Graham Bell, and those people. The jury's out on who really invented it, but they basically used the same technology. The difference was, instead of having like this magnetic tapping thing going on, they created these diaphragms that were hooked up to magnets that would feel the vibrations of our voice. The diaphragm would pick up the vibration, transmit it over the wires, same power source and stuff, and then vibrate the diaphragm on the other side so you could hear a person talk. And the difference between a text message, like we talked about, and the actual voice of a person with emotions and feelings and expressions and language and all that stuff was now able to be transmitted. This was by, the late 1800s. By the mid 1950s, every home in America pretty much had a phone in it. Most homes, right? Same with electricity. And those networks that we built to wire those phones together are the same networks that help build our internet. So the internet really runs over the telephone networks. And now we don't think of it as phone networks anymore. We think of it as computer networks. And now the phones run over the computer networks. But the reality is the phones and the telegraph came first. And it's all built off that same basic principle. But the fact is the communication is instantaneous. And that's the huge game changer. If you just think about putting a letter on a boat, waiting 2 months to get like, hey, dad's dead, oh, I better go home for the funeral. Wait, that was 2 months ago, And then if you want to send a response, it's like 4 months later, you're finding out news back and forth. That's ridiculous. And here I am, 7 milliseconds back and forth to Chicago. Crazy, crazy, crazy fast. All right. Now let's talk about the technologies. And I kind of wanted to do this from our Kahoot. We talked about these technologies. And I'm just going to do this very quickly and informally. This is one of the primary technologies that drives most of the innovations we just talked about. It's called twisted pair copper wire. And most of our computer wiring and phone wiring operates on cables like this. And if you look at the anatomy of how this works, there's basically some plastic sheathing. Sometimes on the inside of that plastic sheathing is some metallic foil or braided cabling that helps to provide a magnetic shield to these wires. But then there's pairs of wires twisted around each other, and that's where the name comes from, twisted pair. Now, those wires are used to transmit and receive information. In fact, on a typical network connection, you will have 8 wires or 4 pairs. Only 2 of those pairs are used. So only 4 of the wires are used to do networking. What are the other 2 for? They're spares. That's usually the answer that you get, right? So we actually have more capability in our wiring than we actually use. But the other weird question is, why are the wires twisted? So I'll have you think about this. With old TV sets, when we would try to get signals, we would put up our antennas, and our antennas would, if you guys are watching the Zoom screen, would be up like this, on an angle, not touching each other. If you take the antennas and you could wrap them around each other, instead of receiving signals, guess what happens? They reject signals. And so the twisted pair is done to help shield the data traveling, or the signals traveling over the wires, from electromagnetic interference. And that's also what the shielding, if there's like a foil or a braided wire wrapped around those wires, that's also shielding. It's to prevent outside frequencies from interfering with the frequencies that are traveling over the wires. All right. This technology is built around copper, so all the wires are copper wires, and can be pretty expensive. So why is Wi-Fi so popular? Because it's a whole lot cheaper to hook a computer up to Wi-Fi than it is to hook up wires. I know that when they wired the IT floor up at the Racine in the Racine campus in the technical building, I think we had like a price quote of like $500 per network drop. So for every network jack, that was the cost. For the jack, the wire, the wiring, hooking it up, and making it all work. And so if you have 24 computers in a classroom and multiply that by $500, well, holy cow, that's a lot of money. Or you can buy a $50 wireless card, throw it in the machine, and you don't have to run any of that stuff. So no wonder so many connections now are wireless, because it's just cheaper to do it, right? You don't have to run the physical infrastructure to do it. But I also want you to keep in mind that wires are faster, more stable, and more secure. And so that's why people still use them. Now, another technology that was really big is this, Coax. And Coax is another copper-based technology, but instead of running multiple wires to do the transmission, they use one single wire, one single piece of copper, usually of much larger diameter and capacity than the twisted pair, usually covered by a plastic coating and then a braided shield of either copper or aluminum or whatever, and sometimes foil as well, to reject interference once again. And most of us who are using Spectrum or have cable TV, our internet is coming through that one single wire. And that's kind of bizarre too. They use a different type of way to transmit the data over the wire than twisted pair does. But I want you to think about that. So this is carrying like 3,000 channels of TV, all our internet streaming, all our Zooms, all our up and downs, and whatever we're doing is going over one single wire. Like, wow, that's amazing when you stop and think about it. But the reality these days is that most providers are really bringing your signal, at least all the way to your neighborhood. Now, in some cases in Wisconsin, we are seeing people who are getting AT&T fiber, for example, or way up north, like up in places like Cable, Wisconsin, they have fiber networks that go right to your house. It's expensive. But fiber optic is kind of an interesting technology because it is made basically of fiberglass, which is a form of glass. It's not plastic. It's a form of glass that just happens to be bendable. And the data is transmitted by light as opposed to electromagnetic pulses. And so the bandwidth that travels over even one single fiber of a fiber optic connection is significantly greater than any copper connection can ever provide. But, okay, so here's the but. It has a limited transmission range. So a fiber connection has to have repeaters every so often. It depends on the type of fiber, and I forget what the limitation is. Copper has limitations too. So copper usually has to be repeated, I think, every 300 meters or something to that thing. You can read up on that and study it. And fiber is a little bit shorter. It might be like every 100 yards. So like if you like maybe have an alley in your neighborhood like I do, and I look down the alleyway at all the phone poles and stuff, you'll see these big fat cables. They're like 2-3 inches across, big Mondo cables. Those are the fiber optic trunk lines, by the way. And then every once in a while, you'll notice connected to those are these big black, like oblong shaped boxes. Sometimes they're kind of oval, sometimes they're kind of square. And those are the fiber repeaters. And so the signals have to be repeated. The potential bandwidth with fiber is significantly higher than copper. And as we move into the future, folks, what's going to happen is these fiber optic connections are going to come right into your house. And you might even, if you're hardwiring, hardwire through fiber because the bandwidth will be just that much greater. So this drives most of the global communication technologies. But let's not ignore some that also were around for quite a long time. Here's one, and of course I totally misspelled it. Microwave, right? Microwave. And I'm not looking for the oven, I'm looking for the towers. And this is kind of a bizarre technology too. Have you guys ever driven down the road and you see a tower and it's got these like funky dishes on it like this? These are microwave towers. And here's what's interesting about this. This is a wireless technology, just like radio frequencies are, just like Wi-Fi is. However, it operates at microwave frequencies. Yes, the same frequencies in your oven that cook your food and your popcorn. I think it's pretty fascinating. But up until not that long ago, and in fact, it's still heavily used in some places, this was the technology of choice for sending high bandwidth communication signals across the country. So let's take for a second and think about the state of Wisconsin where we live. If I want to run a wire from Milwaukee to Racine, yeah, it's an arduous task, but the land is pretty flat. We can dig a hole or string it up to a pole and just keep running it, and eventually we get there. But what if you're out in Colorado, you make that wire get all the way to Denver, and then all of a sudden it's like, darn it, I got mountains to climb. I got to run the wires up those mountains. Are you serious? Where do I put the poles? I can't even sink a hole in the rock to put the pole up. And what they did is they basically create a line of sight transmission from tower to tower and relay the signals through microwave from one tower to another. So you can put a tower at the top of a mountain, have one at the bottom, and have another one at the bottom on the other side, and relay the signal wirelessly from one spot to another. And believe it or not, this is the technology that allows us to route our phone calls from the East Coast to the West Coast, and to allow for like live network television signals to be beamed from New York to Los Angeles instantaneously, predominantly through microwave towers. This technology has largely now been replaced with satellite technology, but there are still circumstances where this is the only technology that works in certain regions because of the extreme topography. It is a bizarre technology, but it's still out there. And then we get to the satellite technology. So we all have, maybe experienced or seen satellite dishes on people's homes. So some of us do, like the Dish Network or whatever, like satellite TV. I don't know how many of you guys do that. But what a lot of people don't know is you can also get internet through those services. Now, the one problem with working with satellites is satellites sit usually like, 20,000 miles up in the sky, and then they have to beam the signal 20,000 miles up and then 20,000 miles back. And that's like going around the planet twice, typically. And so you get a latency that's pretty high with satellites. To solve that latency problem, we have people like Elon Musk developing this technology right now called Starlink. And they are basically putting these like low Earth orbit satellites up to provide internet service, and they're starting to deploy. So a lot of places in the West Coast already have this. They're pushing it really heavy in South Africa, and they have these whole series of satellites that sit significantly lower. I don't know what altitude they're at, but I think it's something like 100 or 200 miles as opposed to 20,000. And a lot of people mistake them for UFOs, by the way, because they sometimes shine in the light or reflect it. But this is a big push that they're making, because if we can get a whole network of satellites up that provide our internet, hey, all the wires are gone. We don't even need a router in our house, if you want to start thinking about it that way. And so this is a big growth area that will happen soon. And then, of course, we go to all our radio technologies like, Wi-Fi. And, I'm not sure what I'm going to pull up here, a picture of a router and a Wi-Fi logo. But that's the prevalent technology that we're using in our homes these days. I always tell students, when I first bought the house that I'm living in now, it was an old home, and we bought it with the intent of gutting it and remodeling it. And that's what we did. We stripped every mechanical system out of the house and rebuilt it from scratch. And so we put all new electric, plumbing, heating. And I'm like, well, hey, the walls are open. And this is the late 90s, mind you. I'm like, you know what? I'm going to be really clever. I'm going to wire my house up to be a smart home before anybody else does. And so I went out and I bought this bundled wiring that had 2 coax, 2 fiber, and 2 Ethernet in a bundle. And I ran that to 4 spots in every room in the house through the wall. So I got all this like really intense wiring in the house. And then Wi-Fi came out. So I thought I was being all clever. And now it's like, I do have a bunch of devices hardwired. And I do have the infrastructure in place. If I want to wire my home to be a smart home, all the stuff is there. But even smart home technology, like if you guys have a Ring doorbell at home, or like security cameras or thermostats, they're all on Wi-Fi, right, you guys? So here I thought I was being clever, and then Wi-Fi got popular. And so this is kind of the big technology that's driving a lot of it. But we also have cellular. And a lot of people are actually getting their, not near me, let's just do cell towers and what they look like. And a lot of people don't even know what a cell tower is. So a cell tower typically will look like this. They have this bizarre triangular configuration with usually 3 transmitters on each surface, kind of strategically pointed. They're usually on top of a hill or a prominence or a tower or a building. And every cell provider has to have their own transmitters in an area in order to provide coverage for their customers. So it's not unusual for people who live in strategic high locations to have towers that have multiple cell providers on them. There are farmers, for example, who have a hill on their property that make all their money off of that cell tower by renting it to the phone companies. You know, just for example, we do have this new thing that's happening, which is 5G. And a lot of people don't know what 5G towers look like. They do look different. And I'm trying to find a classic one here. Yeah, some of them do look like this, but this is actually a more typical configuration where it looks like a round cylinder, and they're very indescript. And I'm starting to see them. Maybe this is a better view of it. Of course, there's a lot of conspiracy theories about this, but a lot of them are very, like, here's a really good example of one. They'll look like this. And a lot of them are starting to pop up, and you might have noticed them actually, and like, what's that? Oh, I don't know. You just drive on. But because of the way this technology works, we have to have a lot more of them because the transmission distance is much shorter. And so they have to develop a lot of small scale towers all over the place. So I was driving around downtown Milwaukee the other day with my wife, and I was noticing basically every other block now, there's one of these on the corner. And so that's usually how it starts. Large metro areas, downtowns, and then it starts to spread out. So like if you're rushing out to buy a 5G phone, the reality is most of the areas that you're going to go to are not going to have true 5G available. But this is what they look like, folks. And as you drive around, I think it's kind of neat to kind of try to spot them, because they try to make them a little bit more plain looking than the old-fashioned cell towers. And I'm not really seeing too many good examples of them here. I guess a lot of people haven't taken pictures of them, but some people get suspicious. They see like this, like, what's this thing in my neighborhood? I'm going to Google this. What's this black box doing here? But that's what 5G looks like typically. Some of them will have like these smaller scale transmitters that still point in a triangle, but most of them tend to be round and pretty low to the ground too. All right. That's kind of my little bit of all right, that's what we have to talk about today in terms of the physical and wireless topologies. This video ends here.